Welcome to our journey into the world of database management. In today's digital age, data is everywhere, and managing it efficiently is more important than ever. Databases are the backbone of modern information systems, powering everything from social media platforms to banking applications. Whether you're a beginner or looking to refresh your knowledge, this series will guide you through the essentials of database management. We'll explore what databases are, why they matter, and how they help organizations store, organize, and retrieve information quickly and securely. Let's get started by understanding the basics and setting the stage for deeper learning. Database is an organized collection of data, typically stored and accessed electronically from a computer system. Think of it as a digital filing cabinet, where information is stored in a structured way for easy retrieval and management. Databases can hold anything from customer records to product inventories, and they come in many forms, including relational, NoSQL, and cloud-based databases. Understanding the core concept of a database is the first step in mastering database management. In the next scene, we'll look at the different types of databases and how they're used in real-world scenarios. Databases come in various types, each designed for specific needs. The most common is the relational database, which organizes data into tables with rows and columns. NoSQL databases, on the other hand, are more flexible and can handle unstructured data like documents or graphs. There are also cloud databases, which offer scalability and remote access. Choosing the right type depends on your project's requirements, such as the volume of data, speed, and complexity. Next, we'll dive deeper into relational databases and see why they're so widely used in business and technology. Relational databases are the foundation of many business applications. They store data in tables, where each row represents a record and each column represents a field. Relationships between tables are established using keys, allowing for efficient data organization and retrieval. Popular relational database management systems include MySQL, PostgreSQL, and Oracle. These systems use structured query language, or SQL, to interact with the data. Understanding how relational databases work is crucial for anyone interested in data management. Up next, we'll explore the basics of SQL and how it helps us communicate with databases. SQL, or Structured Query Language, is the standard language for managing and manipulating relational databases. With SQL, you can create tables, insert data, update records, and retrieve information with simple commands. It's a powerful tool that allows users to interact with large datasets efficiently. Learning SQL opens up a world of possibilities, from building applications to analyzing business data. In the following scenes, we'll cover the basic SQL commands and see how they're used in real-life scenarios. One of the first steps in working with a relational database is creating tables. In SQL, the create table command lets you define the structure of your data, including the columns and their data types. For example, you might create a table for customers with columns for name, email, and phone number. Defining tables carefully ensures your data is organized and easy to manage. Next, we'll look at how to insert data into these tables and keep your information up to date. Once your tables are set up, it's time to add data. The insert into command in SQL allows you to add new records to your tables. For instance, you can insert a new customer's details into the customer table. This process is straightforward but essential for building a useful database. Keeping your data accurate and up to date is key to effective database management. In the next scene, we'll see how to retrieve data using select statement. Retrieving information is one of the most common tasks in database management. The select statement in SQL lets you query your tables and pull out exactly the data you need. You can filter results, sort them, and even join data from multiple tables. This flexibility makes SQL a powerful tool for data analysis and reporting. Next, we'll explore how to update and delete records to keep your database current and accurate. Keeping your database up to date sometimes means changing or removing records. SQL provides update and delete commands for these tasks. Update lets you modify existing data, such as changing a customer's phone number. Delete removes records you no longer need. Using these commands carefully helps maintain data integrity and ensures your database reflects the latest information. In the next scene, we'll discuss the importance of data integrity and how to enforce it. Data integrity is all about ensuring the accuracy and consistency of your data over its lifecycle. In database management, this means setting rules and constraints that prevent invalid data from entering your system. For example, you might require that every customer has a unique email address. Enforcing data integrity helps prevent errors and keeps your database reliable. Next, we'll look at how indexes can speed up data retrieval and improve performance. Indexes are special database structures that make data retrieval faster. Think of them as a books index, helping you find information quickly without scanning every page. In SQL, you can create indexes on columns that are frequently searched or sorted. This can dramatically improve performance, especially in large databases. However, indexes also take up space and can slow down data entry, so it's important to use them wisely. Up next, we'll discuss database normalization and why it matters. Normalization is the process of organizing data to reduce redundancy and improve efficiency. By breaking data into related tables and eliminating duplicate information, you make your database easier to maintain and less prone to errors. There are several normal forms, each with its own rules and benefits. Normalization is a key concept in relational database design, ensuring your data is structured logically. Next, we'll explore how relationships between tables work and why they're important. Relationships between tables are at the heart of relational databases. There are three main types: one-to-one, one-to-many, and many-to-many. For example, a customer can have many orders, but each order belongs to one customer. These relationships are established using keys, such as primary and foreign keys. Understanding how tables connect allows you to design flexible and powerful databases. In the next scene, we'll look at how to use joins to combine data from multiple tables. Joins are SQL operations that allow you to combine data from two or more tables based on related columns. There are several types of joins, including inner join, left join, and right join, each serving different purposes. Joins are essential for pulling together related information such as customer details and their orders. Mastering joins will help you unlock the full potential of relational databases. Next, we'll discuss transactions and how they ensure data consistency. Transaction is a sequence of database operations that are treated as a single unit. Transactions ensure that either all operations succeed or none do, maintaining data consistency. This is especially important in scenarios like banking, where transferring money must be completed fully or not at all. Transactions use commands like begin, commit, and rollback to control changes. In the next scene, we'll explore how database security protects sensitive information. Protecting your data is a top priority in database management. Security measures include user authentication, access controls, and encryption. Only authorized users should be able to view or modify sensitive information. Regular backups and monitoring help prevent data loss and detect suspicious activity. In the next scene, we'll look at how backups and recovery plans keep your data safe in case of unexpected events. Regular backups are essential for protecting your database against data loss. Backups create copies of your data that can be restored if something goes wrong, such as hardware failure or accidental deletion. Recovery plans outline the steps to restore your database quickly and minimize downtime. Having a solid backup and recovery strategy is a key part of database management. Next, we'll discuss database performance tuning and how to keep your system running smoothly. Database performance tuning involves optimizing your system to handle queries efficiently and respond quickly. This can include indexing, query optimization, and hardware upgrades. Monitoring tools help identify bottlenecks and areas for improvement. Keeping your database well-tuned ensures a better user experience and supports business growth. In the next scene, we'll explore the role of database administrators and their responsibilities. Database administrators, or DBAs, are responsible for managing, securing, and maintaining databases. Their duties include installing software, configuring systems, monitoring performance, and ensuring data security. DBAs also handle backups, recovery, and troubleshooting. Their expertise keeps databases running smoothly and supports the needs of users and applications. Next, we'll look at the differences between on-premises and cloud databases. On-premises databases are hosted on local servers, giving organizations full control over their data and infrastructure. Cloud databases, on the other hand, are managed by third-party providers and accessed over the internet. Cloud solutions offer scalability, flexibility, and reduced maintenance, while on-premises systems provide more customization and security control. Choosing between them depends on your organization's needs and resources. Up next, we'll discuss database scalability and how to handle growing data volumes. Scalability is the ability of a database to handle increasing amounts of data and users. As your business grows, your database must keep up with demand. Scaling can be vertical by adding more resources to a single server or horizontal by adding more servers. Cloud databases often make scaling easier and more cost-effective. In the next scene, we'll look at distributed databases and how they support large-scale applications. Distributed databases store data across multiple locations, often in different geographic regions. This setup improves reliability, availability, and performance, especially for global applications. Data is synchronized between sites, ensuring consistency and quick access for users worldwide. However, distributed systems also introduce challenges like data replication and network latency. Next, we'll explore NoSQL databases and their advantages for handling big data and unstructured information. NoSQL databases are designed for flexibility and scalability, making them ideal for big data and unstructured information. Unlike relational databases, NoSQL systems can store documents, key-value pairs, graphs, or wide-column data. Popular NoSQL databases include MongoDB, Cassandra, and Redis. These systems are often used in web applications, real-time analytics, and IoT solutions. In the next scene, we'll compare NoSQL and relational databases to help you choose the right one for your needs. Choosing between NoSQL and relational databases depends on your project's requirements. Relational databases excel at structured data and complex queries, while NoSQL systems handle unstructured data and scale easily. Consider factors like data consistency, scalability, and the types of queries you need to run. Both have their strengths and are often used together in modern applications. Next, we'll discuss database migration and how to move data between systems safely. Database migration involves moving data from one system to another, such as upgrading to a new platform or switching to the cloud. This process requires careful planning to avoid data loss and minimize downtime. Tools and scripts can help automate migration, but thorough testing is essential. Successful migration ensures your data remains accessible and secure. In the next scene, we'll look at data warehousing and how it supports business intelligence. Data warehouse is a specialized database designed for reporting and analysis. It collects data from multiple sources, cleans and organizes it, and makes it available for business intelligence tools. Data warehouses support complex queries and large-scale analytics, helping organizations make informed decisions. Next, we'll explore data mining and how it uncovers valuable insights from your data. Data mining is the process of discovering patterns and insights from large datasets. Using statistical techniques and machine learning, data mining helps organizations identify trends, predict outcomes, and make data-driven decisions. It's a key part of modern database management and business intelligence. In the next scene, we'll discuss the importance of data governance and how it ensures responsible data use. Data governance refers to the policies and processes that ensure data is managed responsibly and ethically. This includes setting standards for data quality, privacy, and security. Good governance helps organizations comply with regulations and build trust with customers. It's an essential part of database management, especially as data volumes and privacy concerns grow. Next, we'll look at database documentation and why it's important for long-term success. Documentation is the process of recording how your database is structured and how it operates. This includes diagrams, data dictionaries, and usage guidelines. Good documentation makes it easier for new team members to understand the system and helps prevent errors during maintenance or upgrades. It's a best practice that supports collaboration and long-term database health. In the next scene, we'll discuss monitoring and auditing your database for security and compliance. Monitoring and auditing are essential for maintaining database security and compliance. Monitoring tools track performance, detect unusual activity, and alert administrators to potential problems. Auditing keeps a record of who accessed or changed data, helping organizations meet regulatory requirements. Together, these practices protect your data and ensure accountability. Next, we'll look at the future of database management and emerging trends. Database technology is constantly evolving. Recent trends include the rise of cloud-native databases, automation, and the integration of artificial intelligence for smarter data management. These innovations are making databases more scalable, efficient, and intelligent. Staying up to date with new technologies can give your organization a competitive edge. In the next scene, we'll explore the basics of database design and how to plan an effective system. Database design is the foundation of an effective information system. It involves understanding user requirements, defining data structures, and planning relationships between tables. A well-designed database is easy to use, scalable, and supports business goals. Taking the time to plan your design can save you headaches down the road. Next, we'll discuss best practices for maintaining your database over time. Regular maintenance keeps your database running smoothly and prevents problems. This includes updating software, optimizing queries, and cleaning up unused data. Scheduled maintenance reduces the risk of downtime and ensures your system stays secure. It's a routine part of database management that pays off in reliability and performance. In the next scene, we'll look at the importance of user training and support. Training users on how to interact with the database is crucial for success. Well-trained users can enter data accurately, run reports, and follow security protocols. Providing ongoing support helps users solve problems quickly and keeps your database running efficiently. Investing in training and support builds confidence and reduces errors. Next, we'll discuss the role of automation in modern database management. Automation is transforming database management by reducing manual tasks and improving efficiency. Automated backups, monitoring, and updates save time and minimize human error. Tools like scripts and scheduling software can handle routine maintenance, freeing up administrators for more strategic work. Embracing automation helps organizations scale and adapt to changing needs. In the next scene, we'll explore the importance of data privacy and compliance. Protecting personal and sensitive data is a legal and ethical responsibility. Regulations like GDPR and HIPAA set standards for data privacy and security. Compliance means following these rules and documenting your practices. Failing to comply can result in fines and damage to your reputation. Prioritizing privacy and compliance builds trust with customers and partners. Next, we'll discuss the challenges of managing big data and how to overcome them. Data refers to extremely large dataset that traditional databases struggle to handle. Managing big data requires specialized tools and techniques, such as distributed databases, parallel processing, and advanced analytics. These solutions help organizations store, process, and analyze massive amounts of information efficiently. In the next scene, we'll look at the role of cloud computing in modern database management. Cloud computing has revolutionized database management by offering scalable, flexible, and cost-effective solutions. Cloud databases can be accessed from anywhere, making collaboration easier and supporting remote work. Providers handle maintenance and security, allowing organizations to focus on their core business. Cloud computing is now a standard part of many database strategies. Next, we'll explore the basics of database APIs and how they enable integration. APIs, or application programming interfaces, allow applications to interact with databases programmatically. They provide a set of commands for reading, writing, and updating data, making integration with other systems seamless. APIs are essential for building modern web and mobile applications that rely on real-time data. In the next scene, we'll discuss the importance of testing and quality assurance in database management. Testing is a critical part of database management. It ensures that your system works as expected and that data is accurate and secure. Quality assurance involves running tests on queries, backups, and security features. Automated testing tools can help catch errors early and improve reliability. Regular testing keeps your database healthy and reduces the risk of problems. Next, we'll look at the importance of scalability planning for future growth. Planning for scalability means designing your database to handle future growth. This includes choosing the right architecture, using scalable technologies, and monitoring performance trends. Anticipating growth helps you avoid bottlenecks and ensures your system can support more users and data. Scalability planning is an ongoing process that adapts as your organization evolves. In the next scene, we'll discuss the importance of disaster recovery planning. Disaster recovery planning prepares your organization for unexpected events like hardware failures, cyber attacks, or natural disasters. It involves creating backup copies, defining recovery procedures, and regularly testing your plan. A strong disaster recovery strategy minimizes downtime and data loss, keeping your business running smoothly. Next, we'll look at the role of analytics and reporting in database management. Analytics and reporting turn raw data into actionable insights. Database management systems often include tools for generating reports, visualizing trends, and tracking key metrics. These insights help organizations make informed decisions and measure success. Effective analytics require clean, well-organized data and the right tools. In the next scene, we'll discuss the importance of continuous improvement in database management. Continuous improvement is about regularly reviewing and enhancing your database management practices. This includes updating processes, adopting new technologies, and learning from past experiences. Staying proactive helps you adapt to changing needs and maintain a high-performing system. Continuous improvement is a mindset that drives long-term success. In our final scene, we'll summarize the key takeaways from this journey into database management. We've covered a lot of ground in our exploration of database management, from the basics of databases in SQL to advanced topics like scalability, security, and analytics. Effective database management is essential for any organization that relies on data. By applying best practices, staying informed about new trends, and focusing on continuous improvement, you can ensure your data remains a valuable asset. Thank you for joining us on this journey, and we hope you feel empowered to take your database skills to the next level.